was exposed to a lot of competition level mathematics, a lot of extracurricular mathematics that sort of goes beyond what we learn throughout the school curriculum. And that was my sort of driving force to want to do number theory and geometry at university. Yeah, so for me, choosing cryptography was very, very natural. I knew that I wanted to be a pure number theorist.
How are you utilising mathematical procedures in your work, and how does it help with your work?
So I'm lucky, being someone that loves mathematics more than anything. I'm very lucky to be able to say that I do mathematics every day and almost all day. As far as my working life goes, I'm able to do, whether it's sitting up on a whiteboard or looking out the window trying to think of new theories, or actually being on a computer implementing them in code.
How would maths help people in the future?
So mathematics, in my opinion, in my very biased opinion, is only becoming more and more relevant in this ever more digital age. Sort of mathematical things that we're looking for in cryptography is we're looking for problems that are very easy to compute in one direction, but are hopefully impossible to do in another direction. So the way I explain it to my mum or to someone else that doesn't really know any too much or doesn't really know mathematics too deeply is like a Rubik's Cube. So a Rubik's Cube, when you start out with a brand new Rubik's Cube, to jumble it up in one direction is very, very easy, but to solve the Rubik's Cube and to reverse that operation, if you give that to someone who didn't see you jumble it up, is very, very difficult, or is hopefully more difficult than going in one direction. Now, obviously, the three-dimensional Rubik's Cube is still, people on the planet can solve it, and computers around the world can solve the Rubik's Cube problem very easily. But if all of a sudden we go from a three-dimensional space into a 1,000-dimensional space, which we can't even envision geometrically, and then the number of colours on this Rubik's Cube is 2,000, and this is a hypercube in a 1,000-dimensional space, then all of a sudden a problem like scrambling up an 1,000-dimensional Rubik's Cube becomes still easy in that direction, but impossible in the other direction.
What are you doing to stop future problems such as quantum computing?
Good question. So quantum computing is very much the main problem I'm working on at the moment. We should, at some stage in the near future, be expecting what's called a quantum computer. Now, a quantum computer uses this new branch of physics called quantum physics or quantum mechanics, where because of this new style of non-classical physics, apparently we're told that these computers can, in a fraction of a millisecond, they can do operations or solve problems that all of the collective classical computers that currently exist in the world couldn't even solve working in parallel for the life age of the universe.
What would you say to someone who is not very interested or savvy with maths, and how would you motivate them?
Okay, so in my case, I would use a similar technique as to that which worked on me, and that is my love for mathematics grew from doing mathematics, especially doing the type of mathematics, the extracurricular mathematics that I spoke about earlier, where you're inspired to think outside the box, and you're inspired to do a more abstract way of mathematical reasoning, rather than the sort of question-answer style, textbook style mathematics that we often do in the classroom. My love for mathematics grew through solving problems, solving problems that required some level of grit and determination, but also some level of a new clever approach that you maybe hadn't been taught before. These style of problems can be very fulfilling in that they make you feel smarter after you solve them, but then they also make you want to keep doing more mathematics, keep solving more problems. And in my experience, doing this sort of thing, as my love for mathematics grew, I became better at it, and then as I became better at it, I fell more in love with mathematics. So my way of trying to motivate anyone that's not mathematically savvy or that's not too interested in this sort of mathematics would be to give them problems and to let their eyes light up as we approach answers and solve things.
Thank you, Craig.
Thanks.